Given the parent function f of x equals log raised 2 of x, write the equation that would describe each transformation. So remember, with logarithms, by nature, we have an asymptote at 0. So let me kind of draw this right here. A vertical asymptote at x equals 0. That's the asymptote. And right now what I'm doing is I'm talking about log base 2 of x. And if you start plugging in values, like so for example, if x was equal to 1, you'd have 2 to the first equals 2. So if we plugged in, I'm sorry, I'm plugging this equation wrong. If you had x equals 1, you'd have log base 2 of 1. That means 2 to what power gives me 1? The answer is 2 to, or 0 to the any as a power always gives you 1. So this would be the value 1 comma 0. And if x equal 2, you'd be saying log base 2 of 2, what power gives of 2, what 2 to what power? I'm sorry, the base of 2 raised to what power gives me 2? Answer 1. That's my y, this is my x, so this would be 2 comma 1. And you could go on, I'll skip to 4. Log base 2 to the number 4. What power of 2 gives me 4? The answer is 2, so this would be 4 and 2. And you could plot these points. Now, as I look at these, that's what I'm going to compare it to. What would describe each transformation? This, if I look at my good points, I see I have a point here at 1, negative 1. I have this point, let me write below. So I have 1, negative 1. I have this point here, which is 2, comma 0. And then I have this point here, which would be 4, comma 1. As I compare these to one another, I find out that the only thing that's happened is these, the y's have been subtracted by 1. So this is equal to f of x with the y's being subtracted 1, so on the outside, or you could write it like this, log 2 of x, and then have the minus 1 out here. Make sure that this x is alone on the inside, that's on the outside. So you could write it either of these two ways. All right, this next one, h, let's see there are points here. The points I'm seeing that are good, I see this point, and this one, and there's not any going off. There's another one that's going to show up probably about out here, but it's not there yet. But I do see that my asymptote has been moved. It's been shifted one right. So that's my guess, is that the whole equation has been shifted one right. Let's see the points. I have 2 comma 0, and I have 3 comma 1. Are these 2 points shifted right one? They are. You see how these have just been shifted right one. So this would be the equation log to go right one. On the inside, it lies, so you do minus 1 on the inside with x. Also written as f of x minus 1 like this. Just like how I said earlier, we could write g of x as f of x plus 1. Okay, and then we come over to j. I'm looking for my points here, here, and there. Again, this hasn't been shifted left or right. My asymptote's there, so I don't have to worry about that, and I should have put that asymptote on this one. I come over here in green, so my points, my good points are 1 comma 1, 2 comma 2, and 4 comma 3. As I compare these points, I see that the y values have just been shifted up 1. These, compared to these, the y values have just been shifted up 1. So, how do you shift the equation up 1? On the outside, I add 1. So j of x could also be written as f of x plus 1 on the outside. Finally, we come to k of x. This one, it looks like it's been shifted left 1 unit, because x equals negative 1 there. You can check. We got 0, 0 is a point. 1 comma 1 is a point. And 3 comma 2 is a point. As I check these, each one of these has been shifted left 1 unit. So that is how you do so. The shift left, remember, inside lies. So this would be x plus 1 on the inside. Or you could write it as k of x equals f of x plus 1. That's how you'd shift left 1.